What if I told you that for your entire life, every birthday, every sunrise, every moment you've existed, something invisible has been circling our sun, and we've only just begun to suspect it's there? Not a planet. Something far stranger. I want you to sit with that for a moment. Really sit with it. You've lived your whole life thinking you knew where you were. You learned the planets in school: Mercury, Venus, Earth, Mars, the gas giants. Maybe you even remember Pluto before they reclassified it. You were taught that our solar system is mapped, understood, settled science. And that belief is comforting, isn't it? It means home is known. It means the map is complete. But that belief is also completely wrong. You see, I've spent my life showing you the visible world. I've taken you into rainforests where every leaf trembles with hidden life. I've brought you to coral reefs, painted in colors that seem impossible. I've walked beside elephants and whales and creatures so small they live between grains of sand. Everything I've shown you, you could see, you could touch, you could verify with your own senses. But now, in these final years of my life, I find myself captivated by something different, by what we cannot see, by the possibility that our sun, the star that has warmed every living thing on this planet for billions of years, has been dancing with a ghost, an invisible partner we never knew existed. And I need to tell you why this matters, not just to astronomers, not just to physicists, but to you, to how you understand reality itself. This video exists because we're living through one of those rare moments when the address of our cosmic home might be rewritten. Not in some distant galaxy billions of light years away, but right here in the space we call home. NASA, along with research teams across the world, is seriously considering that a primordial black hole, formed less than 1 second after the Big Bang itself, has been orbiting our sun since before the Earth existed. Since before life began, since before anything you recognize as familiar came to be. Now, I know what you're thinking. Black holes? We think of them as cosmic monsters, don't we? Things that devour stars, that rip apart galaxies, that lurk in the centers of distant systems like hungry gods. We think if one were anywhere near us, we'd know. We'd see the effects, we'd be in danger. And we think our own solar system is too well studied, too well mapped, too thoroughly explored to hold secrets this profound. We've sent probes to every planet, we've catalogued asteroids, we've tracked comets. Surely if there was something as significant as a black hole out there, we'd have found it by now. All three of these assumptions are false. Here's what I want to give you in the time we spend together. I want to give you a new way of understanding invisibility, not as absence, but as a fundamental property of how the universe actually works. I want you to realize that mystery isn't something out there in the distant cosmos, but woven into the fabric of our own neighborhood, our own backyard, the space around the star that gives us life. I want to take you inside how science works when it's uncertain, when the evidence whispers rather than shouts, when brilliant minds disagree and the answer hasn't revealed itself yet. Because this is real science, not the neat, packaged version you learnt in textbooks, where every question has an answer in the back of the book. This is science as it actually happens, messy and thrilling and alive. And most importantly, I want you to feel something. I want you to experience the emotional reality of standing at the edge of a discovery that could reshape our understanding of dark matter, of planetary formation, of the very early universe. I want you to know what it feels like to realize that everything you thought was settled isn't, that the map of home is incomplete, that there are still dragons here. But let me reframe something for you, because I think we've been thinking about astronomy wrong. You think astronomy is about what we can see through telescopes, don't you? Pictures of galaxies, images of nebulae, photographs of distant worlds. And yes, that's part of it. But the most important discoveries, the ones that truly change how we understand reality, happen when we notice what's missing. When we read the invisible through its effects on the visible, when we become detectives of the cosmos, piecing together clues that something is there, even though we cannot see it, This is detective work at the largest scale imaginable, and you're watching it unfold in real time. So let me take you on a journey. We're going to begin in the darkness of the outer solar system, in a place so distant that sunlight arrives as barely more than a bright star. We're going to watch how patterns emerge in that darkness, patterns that shouldn't exist, patterns that whisper of something hidden. Then we're going to travel back, not in space, but in time, to less than 1 second after the Big Bang, to understand what primordial black holes are and why they might be the answer to mysteries we've been puzzling over for decades. And then we're going to learn. We're going to extract lessons from this cosmic detective story that apply to your life, to how you think, to how you navigate uncertainty. Because the habits of mind that help us find invisible black holes are the same habits that help us find invisible truths in our own lives. Are you ready? Then let's begin. Deep in the outer solar system, beyond the familiar worlds of Jupiter and Neptune, beyond even the distant ice giant that orbits once every 165 years, there exist strange wanderers. Chunks of ice and rock, some as large as mountains, some as large as countries, following paths through the darkness that make no sense. Let me give you a metaphor, because I've learned that metaphors help us see what data alone cannot. Imagine a shepherd you cannot see, standing in a field you cannot enter, calling sheep into formation. You're standing outside the fence. You can see the sheep, those white dots scattered across green grass, but you cannot see the shepherd. You cannot hear the whistle. You cannot detect any obvious cause for what happens next. But then the sheep begin to move. They gather. They align. They move as one, forming patterns that random wandering would never create. And you know with absolute certainty, something is there. Someone is calling them. You don't need to see the shepherd to know the shepherd exists. The pattern is the proof. This is precisely what astronomers observed starting in 2004. They discovered an object called Sedna, named after the Inuit goddess of the sea, a world of ice orbiting so far from the sun that it takes over 11,000 years to complete one circuit. But it wasn't the distance that shocked them, it was the shape of the orbit. Most objects in the solar system travel in roughly circular paths, or at least ellipses that are reasonably round. But Sedna's orbit was stretched like a rubber band pulled to its breaking point. At its closest approach to the sun, Sedna comes within 76 astronomical units. An astronomical unit, remember, is the distance from the Earth to the sun, about 93 million miles. At its farthest point, Sedna retreats to 937 astronomical units. To put that in perspective, Neptune, the most distant planet in our solar system, orbits at about 30 astronomical units. Sedna goes 30 times farther than that. But here's what troubled astronomers. What could have shaped such an orbit? Neptune couldn't have done it. Neptune's gravity doesn't reach that far. No known object in the solar system could account for Sedna's path. And then they found more. By 2016, they'd identified 6 extreme trans-Neptunian objects, as they called them. Objects like 2012 VP 113, like 2013 RF 98, like 2004 VN 112. I apologize for the names. We haven't been poetic with distant ice worlds. We've been clinical, but these clinical names hide something extraordinary. All 6 of these objects shared something impossible. Their orbits clustered together in a way that random chance simply couldn't explain. Imagine throwing 6 darts at a dartboard while blindfolded and having all 6 land within an inch of each other. The probability of that happening by chance alone was calculated at 0.007%, 1 in 15,000. Something was shepherding these objects. Something was pulling them into alignment. In 2016, 2 scientists named Konstantin Batygin and Mike Brown at Caltech published a paper that sent ripples through the astronomical community. They'd run thousands of computer simulations trying to explain this clustering. And they found that if you added one thing, just one new element to the solar system, everything fell into place. A planet, an undiscovered world 5 to 10 times the mass of Earth, orbiting at an average distance of about 400 to 800 astronomical units from the sun, taking somewhere between 10,000 and 20,000 years to complete one orbit. They called it Planet 9. Now, finding a new planet in our own solar system would be extraordinary enough on its own. But here's where the story turns strange, where it becomes something more than just a search for a missing world. Because a planet that distant, even a planet 5 times Earth's mass, should reflect sunlight. It should glow faintly in infrared light, warmed by whatever internal heat it retains from its formation. It should, with our most powerful telescopes, our most sensitive instruments, be findable. They've been searching for nearly a decade. They've covered vast swaths of the sky where the mathematics says it should be. They've enlisted telescopes from Hawaii to Chile. They've analyzed data from infrared surveys, from optical surveys, from everything we have. They've found nothing. And that's when the story became something I never expected it to become. That's when it turned into a story about invisible things, about ghosts, about the possibility that what we're looking for isn't hiding behind distance or dimness, but behind the very nature of reality itself. What if the shepherd isn't hidden behind distance, but behind the nature of light? What if it's not a planet at all? Now I need to take you somewhere else. I need to take you back. Not to my childhood, though I've lived a long time and seen much change. Not even to the childhood of our planet, though that's 4.5 billion years ago, a span of time the human mind struggles to comprehend. I need to take you back to everyone's childhood, to the childhood of existence itself. Less than 1 second after the Big Bang, the universe was nothing like what you see when you look up at the night sky. There were no stars, no galaxies, no planets or moons or anything solid at all. The universe was chaos, a roiling soup of matter and energy at temperatures so extreme that atoms couldn't form. Everything that would eventually become everything was compressed into a space smaller than you can imagine, expanding faster than you can conceive. And in that chaos, in those first fractions of a second, something extraordinary could happen. In certain regions, purely by chance, density fluctuations occurred. Tiny pockets where matter concentrated just a bit more than in the surrounding space. And if that concentration exceeded a critical threshold, space itself couldn't support it. The geometry of reality collapsed. A black hole formed, not because a star died, stars didn't exist yet, but because the sheer concentration of matter and energy in that tiny pocket exceeded what the fabric of space-time could hold. These are called primordial black holes. They're not theoretical fantasies. They're serious candidates for what dark matter might be, or at least part of what dark matter might be. Dark matter, you'll recall, is that mysterious substance that makes up 85% of all matter in the universe, but doesn't interact with light. We know it's there because we can see its gravitational effects on galaxies, on the cosmic web, on the largest structures in the universe. But we cannot see it. We don't know what it's made of. What if some of it, perhaps much of it, is made of these primordial black holes formed in the universe's first moments? For decades, this was purely theoretical. An interesting idea, but one without evidence. And then in 2019, something changed. The optical gravitational lensing experiment, a survey watching millions of stars in our galaxy, detected 6 ultra-short microlensing events. These are flashes, brief moments when a dark object passes between us and a distant star. And the gravity of that dark object bends the starlight, magnifying it like a lens for just a few hours or days. 6 objects drifting through our galaxy, with masses between half an Earth and 20 Earths. Too small to be ordinary black holes formed from dead stars. Too massive to be rogue planets, at least in the numbers detected, but perfectly consistent with primordial black holes. 2 researchers, Jakob Schultz and James Unwin, read about Planet 9 and about these microlensing detections and asked a question that sounds like science fiction but is actually rigorous physics. What if one of those primordial black holes was captured by our sun billions of years ago, during the sun's formation or in the early days of the solar system, when it was still embedded in a dense cluster of young stars? What if it's been orbiting out there ever since? Think about what this means. The odds of capturing a primordial black hole aren't worse than capturing a rogue planet. In the chaotic early solar system, objects were flung in and out all the time. Jupiter probably ejected dozens of Mars-sized worlds. Saturn reshaped the orbits of countless bodies. If a primordial black hole happened to pass nearby at just the right speed and angle, it could have been captured into orbit. The gravitational signature would be identical to a planet of the same mass, completely, utterly identical. But unlike a planet, a black hole doesn't reflect light. It doesn't emit heat in any meaningful way. It is invisible to every telescope we've ever built, every instrument we've ever designed to look at the sky. Let me tell you how small, and yet how massive such an object would be. A 5 Earth-mass black hole, which is right in the range that would explain the orbital clustering we observe, would have an event horizon, the point of no return, where not even light can escape, just 5 centimeters across. 5 centimeters. The size of a grapefruit. You could hold it in your hands if physics allowed such a thing, which it certainly does not. But its gravitational influence would extend for billions of kilometers. It would sculpt the orbits of distant worlds. It would leave fingerprints across the entire outer solar system. And we would never see it. How do you find something that refuses to be seen? How do you prove the invisible is real? This is the question that haunts me, because it's not just a question about astronomy, it's a question about knowledge itself, about how we come to believe anything is true when we cannot directly verify it with our senses. Let me tell you what I've learned in my long life. I've learned that invisibility is not absence. This might be the most important thing I can teach you today. You see, we built our entire understanding of reality on a foundation of sensory experience. From the time you were born, you learned that what you can see, touch, hear, taste, smell, those things are real. A toy you can hold is real. A sound you can hear is real. The warmth of sunlight on your skin is real. And by extension, we learn to distrust or dismiss what we cannot sense. If you can't see it, if you can't touch it, maybe it's not really there, maybe it's imaginary. But the universe doesn't care about our senses. The universe operates through forces we cannot see, acting on scales we cannot directly experience. And yet these invisible forces shape everything. Gravity. You cannot see gravity. You cannot touch it, bottle it, photograph it. And yet gravity holds you to the Earth. It keeps the Earth in orbit around the Sun. It binds galaxies together across millions of light years. It bends space itself. Dark matter. We cannot see it, cannot detect it with any instrument that measures light. And yet it outweighs all the stars and planets and gas clouds in the universe combined. Without dark matter, galaxies would fly apart. The universe as we know it would not exist. Magnetic fields, time dilation, the expansion of space itself, quantum fields that permeate every point in the universe. None of these can be photographed, held, or touched. And yet they are fundamental to reality. So when we talk about a black hole 5 centimeters across orbiting in the darkness beyond Neptune, we're not talking about something imaginary. We're talking about something that might be profoundly real, but expressed entirely through invisible forces. A 5 Earth-mass black hole and a 5 Earth-mass planet pull with identical gravitational force. From a distance, they're indistinguishable. The orbits they create, the perturbations they cause, the clustering they produce, all identical. This is the paradox that should shake you. The universe operates through forces we cannot see, and yet we've built our entire understanding by interpreting these invisible influences. Stop trusting your eyes as the final arbiter of truth. Reality is written in effects, not appearances. Let me tell you a story from history, because history teaches us and humbles us in equal measure. In 1781, William Herschel discovered Uranus, the first planet found in recorded history that wasn't known to ancient peoples. It was a triumph of the telescope, of systematic observation. But within a few decades, astronomers noticed something wrong. Uranus wasn't moving quite as it should. Its orbit deviated from the predictions of Newton's laws, just slightly, but measurably. Two possibilities existed. Either Newton's laws were wrong, which seemed unlikely given how well they worked everywhere else, or there was another planet out there, unseen, tugging on Uranus with its gravity. In 1846, a French mathematician named Urbain Le Verrier sat down with sheets of paper and did something extraordinary. He calculated, based purely on the deviations in Uranus's orbit, exactly where this unseen planet should be. He worked backward from effects to cause, from visible perturbations to invisible mass. He wrote to an astronomer in Berlin named Johann Galle. He pointed at an empty patch of sky and said, in effect, look there. Within 1 hour of searching, Galle found Neptune, right where the mathematics predicted, within 1 degree of Le Verrier's calculated position. Le Verrier never saw Neptune before predicting it. He didn't need to. The mathematics told him everything. The invisible was revealed through its effects. We're attempting the same thing now, but with a challenge that makes Neptune look easy. Neptune was large, relatively close, and orbiting on a timescale of 165 years, which meant astronomers could observe its effects on Uranus over multiple orbits. Planet 9, or the black hole, whatever is out there, is so distant and slow-moving that it takes 10 to 20,000 years to orbit. We've been watching for maybe 200 years with instruments sensitive enough to detect these effects. That means we've observed a tiny, tiny fraction of one orbit. It's like trying to predict the full shape of an elephant after touching only its tail for 3 seconds while blindfolded. And yet, the mathematics is compelling. Computer simulations run by Battigan and Brown show something remarkable. When you add a 5 to 10 Earth mass object on a highly eccentric orbit several hundred astronomical units out, tilted at an angle to the plane of the planets, the simulations reproduce not just the clustering of orbits we observe, but also something else, something no one was trying to explain. High inclination trans-Neptunian objects. These are worlds tilted nearly perpendicular to the solar system's plane, orbiting almost vertically compared to the planets. They were discovered years before Planet 9 was proposed. No one could explain why they existed. They were anomalies, outliers, strange things we filed away as interesting but mysterious. The simulations with Planet 9 explained them naturally. They fell out of the mathematics without anyone trying. That's when you know you might be onto something real. When the hypothesis you create to explain one mystery accidentally explains others you weren't even thinking about, the universe speaks in patterns. If you learn the language of mathematics, you can hear what cannot be seen. But here's what troubles some scientists, and what makes this search so precarious and so human and so important to understand. A researcher named Samantha Lawler and others have raised a critical point about observational bias. You see, we only find objects where we look. This sounds obvious, but the implications run deep. Most of the extreme trans-Neptunian objects that support the Planet 9 hypothesis were discovered by surveys focused on specific regions of the sky. Not because those were the only regions worth looking at, but because telescope time is precious, funding is limited, and astronomers have to make choices about where to point their instruments. If you only search certain areas, of course you'll find clustering there. That's not evidence of a hidden planet, that's evidence of incomplete data. It's like searching for lost keys only under the streetlight because that's where you can see, and then concluding that keys cluster near streetlights. The Outer Solar System Origin Survey, a different team using different methods, found over 800 trans-Neptunian objects and detected no significant clustering. They looked more uniformly across the sky and found objects scattered in ways that seemed random. But Battigan and Brown counter with their own valid point. Most of those 800 objects are too close to Neptune to be influenced by Planet 9. The truly distant objects, the ones beyond what we call the scattered disk, beyond 50 or 60 astronomical units in a stable way, those are rare. We simply haven't found enough of them yet to say with certainty whether the clustering is real or bias. This is science at its most honest. This is what science actually looks like when the answer hasn't arrived yet. Smart people disagree. Data is incomplete. Multiple interpretations exist, and we don't know which one is correct. We don't know what we don't know, and our ignorance can masquerade as knowledge if we're not careful. So what's the resolution? How do we settle this? More data, always more data. The universe doesn't yield to arguments or eloquence or confidence. It yields only to observation. The Vera C. Rubin Observatory in Chile is beginning operations in 2025. It has a mirror 8.4 meters across and a camera with 3.2 billion pixels, the largest digital camera ever built for astronomy. It will survey the entire visible sky every few nights, over and over, for 10 years. Within its first year of operation, the Rubin Observatory will discover thousands of new trans-Neptunian objects. Thousands. It will map the outer solar system with a completeness we've never achieved before. If the clustering is real, if it's not just a product of where we've happened to look, it will become unmistakable, undeniable. And if the clustering is bias, if it dissolves when we look more uniformly, then the case for Planet 9 collapses. The mystery returns to being a mystery, but without a clear direction. Patience. The universe reveals itself not to those who guess, but to those who wait and watch. But I need to tell you about the ghosts we've chased before, because humility matters. Science has a history of finding invisible things that weren't there. In the 19th century, Mercury's orbit showed anomalies that Newtonian physics couldn't explain. The planet moved slightly differently than calculations predicted. Following the success with Neptune, astronomers proposed Vulcan, a planet orbiting between Mercury and the Sun, hidden in the Sun's glare. Searches were conducted. Some astronomers even claimed to have seen it during solar eclipses. But Vulcan didn't exist. It never existed. Einstein's general relativity, published in 1915, explained Mercury's orbit without needing a hidden world. The anomalies were real, but the cause wasn't an unseen planet. It was the curvature of space-time near the Sun. Then there's Planet X. Percival Lowell, the astronomer who built the Lowell Observatory in Flagstaff, Arizona, became obsessed with finding a planet beyond Neptune. He believed there were irregularities in the orbits of Uranus and Neptune that pointed to another world. He died in 1916 without finding it, but the search continued. In 1930, Clyde Tombaugh, working at Lowell Observatory, discovered Pluto. For a moment, it seemed Lowell had been right. Planet X had been found, but Pluto was too small. Far, far too small. It couldn't possibly cause the perturbations Lowell had claimed to detect. Later, when we sent Voyager 2 past Neptune and got accurate measurements of its mass, we recalculated the orbits. The perturbations themselves vanished. They were measurement errors. Planet X was a ghost, a phantom born from incomplete understanding and imperfect instruments. So we must ask ourselves, and we must ask honestly, is Planet 9 another Neptune, real and waiting to be found? Or is it another Vulcan, another Planet X, a phantom we're chasing because we want mystery more than we want truth? I don't know. No one knows. And that's the point. The history of science is littered with invisible things we were certain existed. Humility is not weakness, it's accuracy. But even if Planet 9 doesn't exist as we imagine it, even if the clustering dissolves or gets explained some other way, the search itself teaches us something profound. It teaches us how to think when answers are absent. It teaches us how to hold hypotheses lightly while working on them seriously. It teaches us that being wrong is part of the process, not a failure of the process. And it teaches us something even deeper, I think. It teaches us that the universe doesn't owe us easy answers, that reality is under no obligation to be comprehensible, convenient, or comforting. And yet we search anyway, we calculate anyway. We build bigger telescopes and wait patiently for data that might take years to arrive. That, to me, is beautiful. That's humanity at its best. Now let me tell you how we might actually detect this invisible thing, if it's a black hole. Traditional telescopes are useless if Planet 9 is a primordial black hole. You cannot photograph darkness. But invisibility doesn't mean undetectable. We just have to be clever about what we're looking for. Method 1. Dark matter halos. Black holes attract dark matter over billions of years. Remember, dark matter is everywhere, pervading the galaxy, and it interacts gravitationally even though it doesn't interact with light. A 5 Earth mass black hole, orbiting in the outer solar system, would gradually accumulate dark matter around it, forming a dense cloud. Now, we don't know for certain what dark matter is made of, but many models suggest that dark matter particles can annihilate when they collide, converting mass into energy in the form of gamma rays, high-energy light far beyond what our eyes can see. The concentration of dark matter around a black hole would make these annihilations more frequent. The black hole would be surrounded by a faint glow of gamma rays, invisible to optical telescopes, but detectable by space-based gamma-ray observatories like the Fermi Space Telescope. Researchers have calculated what this signal would look like and how strong it would need to be to detect. It's faint, very faint, but within the capabilities of our instruments if we know where to look. Method 2. Accretion flares. The outer solar system isn't empty. There are comets, asteroids, stray chunks of ice and rock drifting through the darkness. Most of these objects are too small and too distant for us to detect unless they come close to the Sun and develop tails. But if a primordial black hole is orbiting out there, occasionally one of these objects would fall into it. And when something falls into a black hole, even a small black hole, the gravitational forces are extreme. The object gets torn apart by tidal forces, ripped to shreds, heated to incredible temperatures as it spirals inward. For a brief moment, maybe hours, maybe days, it would produce a brilliant flare of X-rays and other high-energy radiation before disappearing forever into the event horizon. The Vera C. Rubin Observatory, because it surveys the sky so frequently, could catch these flares if we're watching the right region. It would look like a sudden brightening in the middle of nowhere, far from any known object, and then darkness again. Method 3. Gravitational perturbations. This is perhaps the most subtle but also the most certain method if we can achieve the precision needed. A 5 Earth mass object at several hundred astronomical units would slightly perturb the orbits of the giant planets: Jupiter, Saturn, Uranus, Neptune. The effects would be tiny, just meters over decades, but potentially measurable with precise enough instruments. We've been tracking these planets for centuries now with increasing accuracy. If we can extend that tracking, if we can measure positions to within a few kilometers across billions of kilometers of space, the perturbations from Planet 9 or a black hole would eventually become detectable. This requires patience. It requires decades of continuous observation. But it's certain. Gravity cannot hide. Gravity always leaves traces. Method 4. Spacecraft probes. This is the most direct but also the most expensive and time-consuming method. We could send a fleet of small probes, CubeSats perhaps, toward the outer solar system. They don't need to reach the black hole or Planet 9 itself. They just need to pass near enough to detect tiny deviations in their trajectories caused by its gravity. By launching multiple probes in different directions and tracking their positions precisely, we could triangulate the location of the unseen mass. It would take years, perhaps decades, for the probes to travel far enough, but it would work. When you cannot see something directly, measure its influence. Reality always leaves fingerprints. But here's what haunts me, and I want to be honest with you about this. We cannot prove Planet 9 doesn't exist. We cannot prove the primordial black hole hypothesis is wrong. Absence of evidence in a region we've barely explored is not evidence of absence. We've looked at perhaps 1% of the sky where Planet 9 might be, and that's being generous. The outer solar system is vast beyond comprehension. Even with our best telescopes, even with systematic surveys, there are enormous regions we simply haven't observed carefully enough. So we cannot say with certainty that nothing is there. But we also cannot prove it does exist. Not yet. Perhaps not for years. Perhaps not for decades. This is where science becomes less about declaring truths and more about testing competing hypotheses, watching them make predictions, and seeing which predictions come true. Planet 9 predicts specific orbital clustering. Observational bias predicts that clustering should diminish as we survey more uniformly. The primordial black hole hypothesis predicts gamma-ray signatures or accretion flares in a specific region. Modified Newtonian dynamics. A different theory some physicists propose predicts that apparent gravitational anomalies should appear everywhere, not just in our solar system. Each hypothesis makes predictions. Each will be tested by future observations. Some will be ruled out, some will gain support. And maybe, just maybe, one will be confirmed. Or maybe we'll discover something we didn't expect at all, something stranger. The universe has a history of being stranger than we imagine. Uncertainty is not failure. It's the precondition for discovery. The universe doesn't owe us easy answers. So what do we do while we wait? How do we live with this kind of cosmic uncertainty? How do we function when the map of home is incomplete? I want to give you some practices, some ways of thinking and being that this search for Planet 9 has taught me, not abstract philosophies, but concrete things you can do in your own life. First practice, learn to read the invisible in your own life. You've now seen how astronomers detect things they cannot see by measuring their effects. The clustering of orbits reveals the shepherd, even when the shepherd is hidden. Apply this to your own experience. For 1 week, notice the invisible forces shaping your behavior. Not vague concepts, concrete things. The gravity of habit. Why do you check your phone at certain times? What invisible routine is pulling you? The dark matter of relationship dynamics. Whose approval are you unconsciously seeking? Whose opinion shapes your choices even when they're not in the room? The orbital perturbations. What small, recurring frustrations keep appearing in your life? What pattern keeps repeating? These are not random. They're evidence of something deeper, something you might not be seeing directly. Write them down. Don't solve them yet. Don't judge them. Just observe. Train yourself to see reality, not through what's obvious, but through what patterns emerge over time. This is harder than it sounds. We're very good at fooling ourselves, at not seeing what we don't want to see. But the patterns don't lie. If you show up late to things you claim to care about, that's not bad luck. That's a pattern pointing to something invisible. Fear, ambivalence, poor planning, something. If you find yourself in the same conflicts with different people, that's not other people's fault. That's an orbit, and you're part of the system creating it. Read the invisible through its effects. Second practice, embrace provisional belief. Scientists working on Planet 9 hold their hypothesis lightly. They believe it's likely true based on current evidence, but they're prepared to be wrong. They're not emotionally attached to being right. They're attached to finding out what's actually true. This isn't weakness. This is intellectual honesty. This is maturity. Choose one belief you hold strongly. Anything. A political belief, a belief about yourself, a belief about how the world works. Now ask yourself, what evidence would change my mind? If the answer is nothing, if you can't imagine any evidence that would make you reconsider, you're not holding a belief. You're clinging to an identity. An identity is immune to evidence. Practice saying, even just to yourself, I think this is true, but I could be wrong. I believe this based on what I know now, but I'm open to new information. This isn't relativism. This isn't pretending all beliefs are equally valid. Some beliefs are supported by mountains of evidence. Some are supported by wishful thinking. But even well-supported beliefs should be held provisionally, because that's what allows us to update when reality teaches us something new. The scientists who found Neptune were open to the possibility that Newton's laws needed modification. They weren't, but they were open. The scientists searching for Planet 9 are open to the possibility that the clustering is observational bias. It might be, but they're open. That openness is what makes science work. It's also what makes humans wiser. Third practice, track your attention like an orbit. The trans-Neptunian objects beyond the Neptune cluster, not randomly, but in response to an unseen force. Your attention works the same way. For 3 days, notice what naturally captures your attention without effort. Not what you think should interest you, not what your teachers or parents or society says is important. What actually draws you in? What do you read about voluntarily when no one's making you? What do you think about in free moments? What questions keep returning to your mind even when you try to focus on something else? These patterns point to something deeper. They point to a gravitational center in your psyche, a core interest or calling or concern that's pulling on you even if you haven't named it yet. Most people spend their lives fighting their natural attention, trying to force themselves to care about things they don't naturally care about, while ignoring the gravitational pull of what actually matters to them. Instead of fighting it, investigate it. What invisible force is shaping your curiosity? What is your attention trying to tell you? Maybe you keep reading about history, or maybe you're drawn to stories about people overcoming illness, or maybe you find yourself fascinated by how things are built. Don't dismiss these patterns. They're data. They're telling you something about who you are and what you might be here to do. Your attention is not random. Neither are the orbits of distant worlds. Both are responding to gravity, to forces deeper than surface explanation. Fourth practice, make peace with waiting. The Rubin Observatory will begin full surveying operations in 2025. Within a year or two, we'll have dramatically more data about the outer solar system. Within 5 years, we'll have enough to say with much greater confidence whether Planet 9 exists or not. But the answer might still not be clear. Some discoveries take decades. Neptune was predicted in 1846 and found almost immediately. But Pluto, even after Attenborough discovered it in 1930, took until 2006 before we understood it well enough to reclassify it as a dwarf planet. Some questions don't have quick answers. Identify one important question in your own life where you're desperate for an answer right now. Maybe it's about your career, maybe it's about a relationship, maybe it's about your health or your purpose, or whether to make a big change. Practice this sentence and mean it. I don't know yet, and that's okay. The data will come when it comes. This is not resignation. This is not giving up. This is recognizing that some questions require time to answer properly, and rushing to a conclusion based on incomplete information often leads to the wrong answer. Impatience is ego. Ego says, I should know this now. I deserve clarity now. The universe should organize itself around my timeline. Patience is respect for complexity. Patience says, this is complicated, and complicated things take time to understand. I can wait. I can keep gathering information. I can live with uncertainty a bit longer if it means eventually arriving at truth rather than premature certainty. The astronomers searching for Planet 9 have been at this for almost a decade. They don't know if they'll find it this year or in 5 years or ever. And yet they keep searching, keep refining their models, keep checking new regions of sky. That patience, that willingness to live in the question is part of what makes the eventual answer meaningful. Fifth practice, study one thing deeply. Astronomers tracking these distant objects have been at it for 2 decades now. They know these worlds intimately. They know their orbits, their compositions, their sizes, their albedos, their histories. They know which discoveries came from, which surveys, which observations are most reliable, which models fit the data best. Deep knowledge comes from sustained attention, not clever insights, not quick summaries, but years of patient observation. Choose one subject, anything, and commit to learning about it for 30 minutes a day for a month. Not for career advancement, not to impress anyone, not to add a skill to your resume, just to experience what it feels like to know something well. It could be the history of your neighborhood, it could be how birds migrate, it could be how engines work, or how bread rises, or the life of one poet, or the dynamics of one ecosystem. It doesn't matter what it is. What matters is that you stay with it long enough to move past the surface, past the Wikipedia summary, into the depth where real understanding lives. The modern world rewards breadth. We're supposed to know a little about everything, to be conversant in many domains, to skim and summarize and move on quickly. And there's value in breadth, but depth is where meaning lives. Depth is where you discover that simple things are complex and complex things have elegant cause. Depth is where wonder happens, because wonder requires time. You cannot be struck by the beauty and intricacy of something if you're only glancing at it. Astronomers studying trans-Neptunian objects have spent thousands of hours watching tiny points of light move across the sky. To most people, these observations would be boring. But to them, each new data point is treasure. Each refined orbit is a piece of a larger puzzle. They're not just collecting facts, they're building intimacy with a region of space. You can build that kind of intimacy with anything. It changes how you see the world, it changes how you think, you start to notice patterns others miss, you start to ask questions others don't think to ask, and you develop judgment, the ability to distinguish between what matters and what doesn't, what's signal and what's noise. This is what education should be, but often isn't. Not the accumulation of facts to pass tests, but the cultivation of deep attention, the ability to stay with something long enough to truly understand it. Pick one thing, 30 minutes a day, 1 month, see what happens. Now, let me bring us back to where we started, because I want to close this journey with you in a way that honors both the science and the deeper meaning beneath it. We began with a question: why does NASA suspect a black hole is orbiting our sun? The answer, on its surface, is technical. The mathematical evidence is compelling. 6 extreme trans-Neptunian objects showing orbital clustering with a probability of 1 in 15,000 of occurring by chance. Computer simulations that reproduce this clustering when you add a 5 to 10 Earth mass object on a distant, eccentric orbit. The primordial black hole hypothesis, which explains why we haven't found Planet 9, despite searching for nearly a decade with our most powerful telescopes. We have mechanisms for detection: gamma ray signatures from dark matter annihilation, accretion flares from captured comets, gravitational perturbations on the giant planets, spacecraft trajectories that could triangulate the unseen mass. The tools exist. The methods are sound. We're not speculating wildly. We're following evidence. But the deeper answer, the one that matters more than the technical details, is this: we suspect it because we've learned to listen to the universe's whispers, not just its shouts. For most of my life, I've narrated the visible world. I've taken you into jungles where every sound is life calling to life. I've shown you creatures emerging from chrysalises, their wings wet and crumpled, slowly hardening into instruments of flight. I've walked beside elephants as they mourn their dead, touching the bones with their trunks in rituals we're only beginning to understand. I've brought you to coral reefs, where color and form combine in ways that seem almost unreal. Everything I've shown you, you could see. You could verify with your own eyes that these things exist, that these moments happen, that this world is as wondrous as I've claimed. But now, in these final chapters of my life, I find myself drawn to what cannot be seen, to the possibility that a black hole, the size of a grapefruit, has been orbiting our sun since before the Earth existed, to the reality that most of the universe is made of something we cannot detect except through its gravity, to the understanding that the forces shaping everything, from the largest galaxies to the smallest atoms, are invisible. And I find this not frightening but profound, because the lesson of Planet 9, whether it's a planet or a black hole or a phantom born from incomplete data, is that reality is not limited to what our senses can reach. The universe is speaking all the time, in the language of gravity, pulling distant worlds into alignment, in the curvature of space-time, bending light around massive objects, in the subtle perturbations of orbits, whispering that something unseen is there. We are living through one of those rare moments when the map of home is being redrawn, not in some abstract, distant future, right now, in our lifetime, in yours and mine. Within the next few years, the Rubin Observatory will survey thousands of trans-Neptunian objects. We'll know with far greater certainty whether the clustering is real or observational bias. We might detect gamma ray signatures pointing to a specific region of sky. We might catch an accretion flare, a brief, brilliant flash from the darkness. We might refine our measurements of planetary orbits enough to see the gravitational fingerprints of Planet 9. Or we might discover something we didn't expect at all, a disk of smaller bodies instead of one large planet, a different explanation for the clustering, evidence that our understanding of gravity needs refinement at these scales. Or maybe the mystery will deepen. Maybe we'll have more data, but still not enough to conclude. Maybe we'll have to live with uncertainty a while longer, with the question hanging in the air like the smell of rain before a storm. Either way, you've been here for it. You've watched science unfold, not as a collection of facts in a textbook, where every question has an answer in the back of the book, but as a living process. Uncertain, messy, thrilling, fully human. You've seen how scientists think when they don't know the answer yet, how they build hypotheses carefully and test them rigorously, how they disagree respectfully, how they change their minds when evidence demands it, how they hold confidence and doubt in the same breath. This is real science. This is how we actually learn things about the universe. Not through declarations of certainty, but through patient observation, through following evidence wherever it leads, through being willing to be wrong if that's what reality requires. And I think there's something deeply moving about this, about our species, barely out of the caves in cosmic terms, building instruments sensitive enough to detect worlds billions of kilometers away, about us doing the mathematics to predict where invisible objects might be hiding, about us having the patience to wait years or decades for confirmation, about us being humble enough to say, we don't know yet, but we're working on it. That capacity to face mystery with curiosity rather than fear, to say, I don't know, but I want to find out, that might be the best thing about us. Here's what I want you to remember. This is important, so listen closely. You are not separate from this cosmos. You are not an observer standing outside looking in at something foreign and distant. You are made of stardust, literally, atoms forged in the hearts of exploded suns that died billions of years ago so that you could be here. You are orbiting a star that might be dancing with an invisible partner, in a galaxy full of mysteries we're only beginning to understand, in a universe that extends farther than we can observe. Your life too is shaped by forces you cannot see. The gravity of your upbringing, pulling on you in ways you might not recognize. The dark matter of your unconscious mind, making up most of who you are, but invisible to direct inspection. The orbital resonances of your relationships, the way you and the people you love influence each other's trajectories just by existing in proximity. None of this is mysticism. This is simply acknowledging that invisibility is fundamental to existence, that what we cannot see is often more important than what we can. That reality operates on levels beyond our direct perception, and learning to read those levels, learning to detect the invisible through its effects, is how we grow wiser. So I'll give you an affirmation, and I want you to say it with me, either out loud or in your mind. Mean it when you say it. I do not need to see something to know it's there. I trust the patterns. I read the invisible. I wait, I watch, and I remain curious. Say it again, feel what it means. I do not need to see something to know it's there. I trust the patterns. I read the invisible. I wait, I watch, and I remain curious. This is not just about astronomy. This is about how you'll navigate everything. Relationships where the important things are felt, not said. Career decisions where the path forward is uncertain. Personal growth where the changes are internal and gradual and impossible to photograph. You'll need to trust patterns. You'll need to read the invisible. You'll need to wait for data, watch for effects, and remain curious, even when answers don't come quickly. The universe has given you a masterclass in this through the search for Planet 9. Let it change how you think. Let it change how you see. Let it change how you wait. If this video has changed how you think about the universe, or about uncertainty, or about invisibility, or about the edges of human knowledge, I'd love to hear from you. Leave a comment. Tell me what invisible forces are shaping your life right now. Tell me what patterns you're noticing. Tell me what you're waiting to understand. Because this conversation doesn't end with me talking to you. It continues with you talking to each other, with you taking these ideas and testing them in your own lives, with you becoming people who can sit comfortably with mystery while still searching for truth. If you want more explorations like this, if you want to stand at the edge of understanding where science and philosophy and the human experience meet, subscribe. Not because I'll give you easy answers, I won't, but because I'll help you ask better questions. And better questions, I've learned in my long life, are more valuable than easy answers. And if you found this valuable, if it moved something in you, share it with someone who's comfortable not knowing. Those are the people who will inherit the future. Those are the people who'll make the next great discoveries, who'll solve the problems that don't have solutions yet, who'll live with grace in a world that's always more complex than we'd like it to be. Until next time, keep looking up, watch the night sky, and remember that most of what's out there we cannot see. Keep looking inward too. Notice the invisible forces shaping your choices, your thoughts, your trajectory through life. Both directions are infinite. Both are worth exploring. And both will teach you that the invisible is not the opposite of real. It's often more real than anything you can touch. Thank you for spending this time with me. Thank you for being curious enough to wonder whether a black hole might be orbiting our sun. Thank you for being patient enough to sit with uncertainty. Thank you for being wise enough to know that not knowing is not the same as not caring. The search continues. The telescopes keep watching. The data keeps accumulating. And somewhere out there, in the darkness beyond Neptune, in the cold and silent reaches of our solar system, something might be waiting to be found. Whether it's a planet, or a black hole, or something we haven't imagined yet, the search itself ennobles us. The willingness to look, to calculate, to wait, to wonder, that's what makes us human in the best sense of the word. So go forth with eyes open to the invisible. Trust the patterns, read the effects, wait for evidence, watch for surprises, and remain endlessly, boundlessly, beautifully curious about this strange and wondrous universe we call home, because we're all searching for invisible things. All of us. Some of us search for invisible planets. Some of us search for invisible meanings. Some of us search for invisible connections, invisible purposes, invisible truths about who we are and why we're here. The methods are the same. Pay attention. Notice patterns. Don't jump to conclusions. Wait for evidence. Hold your beliefs lightly. Stay curious even when, especially when, the answer is unclear. And know that you're part of something extraordinary. You're part of a species that can detect worlds it cannot see. That can predict the positions of objects billions of kilometers away using nothing but mathematics and patience. That can propose invisible black holes, orbiting invisible orbits, and design experiments to test whether such impossible things might be real. That's us. That's you. You're part of this great adventure of understanding, not just watching it, but living it, thinking about it, letting it change how you see everything. So the next time you look up at the night sky, remember, most of what you're looking at you cannot see. The dark matter that outweighs all the stars. The invisible forces that curve space and time. The possible black hole orbiting somewhere in that darkness, silent and invisible but real. And remember too that you are made of the same stuff as those stars, that the atoms in your body were forged in stellar furnaces, that you are the universe looking at itself, trying to understand itself, searching for invisible truths with the tools of reason and patience and wonder. That's not poetry, that's physics, that's astronomy, that's the literal truth of what you are. So wear that truth lightly but seriously. You are a cosmic detective, whether you think of yourself that way or not. You are searching for invisible things every day. The question is only whether you search mindfully or mindlessly, whether you notice the patterns or miss them, whether you trust the process or demand premature certainty. I've given you the tools. I've shown you how astronomers think, how they search, how they wait. Now it's yours to use. Go read the invisible. Go trust the patterns. Go wait with patience and watch with attention. The universe will speak to you. It speaks to everyone who listens. And maybe, just maybe, within your lifetime or mine, we'll know for certain. We'll confirm that Planet 9 is real, or we'll detect the gamma rays from a primordial black hole, or we'll discover something even stranger hiding in the darkness. Or maybe we won't. Maybe the mystery will outlive us both. We'll pass to future generations to solve with future telescopes and future insights. Either way, the search was worth it. The wondering was worth it. The learning to think this way, to see this way, to wait this way, that was worth everything. Because in the end, that's what we're really searching for. Not just a planet or a black hole, but a way of being human that's curious and humble and patient and wise. A way of living that can hold uncertainty without anxiety, that can follow evidence without rigidity, that can change its mind without losing its center. That's the real treasure. That's what this journey has been about. So take it with you, use it, teach it to others, live it in your own way, and know that somewhere right now, astronomers are pointing telescopes toward regions of sky where they think Planet 9 might be hiding. They're analyzing data, refining models, planning observations for years from now. They're living in the question, doing the work, trusting the process. You can do the same. Whatever your questions are, whatever invisible things you're searching for, you can approach them the same way, with patience, with rigor, with humility, with wonder. That's how we find what's hidden. That's how we understand what seems incomprehensible. That's how we become who we're meant to be. Thank you for being here. Thank you for listening. Thank you for caring about invisible black holes and distant orbits and the edges of what we know. The universe is richer because you wondered about it. Your life is richer because you took the time to understand it more deeply. Keep that going, keep wondering, keep searching, keep reading the invisible through its effects. That's what it means to be fully alive. That's what it means to be fully human. Until we meet again in another video about another mystery at the edge of understanding, take care of yourself, take care of each other, and take care of this precious, improbable, wondrous world we all share. The search continues for all of us, in all directions, forever. And that's exactly as it should be.